This is a video showing how to capture the amplitude function of a decaying exponential. In this case, we've captured the velocity values for an oscillating disk that's oscillating about its equilibrium point. You can see the amplitude of these oscillations is decreasing over time. It can be helpful to capture the envelope function for this decaying oscillation. To do that, it's going to be best to use a calculator. I'll go over to the left-hand side and select the calculator. The best function to take care of this is the amplitude function. So this amplitude function lives under this special button down below, and if you mouse over the button for the amplitude function, you can see there's a full description of this function that's given below. There are 4 arguments to this function: peak, valley, time, and then x, which defines the measurement or calculation to which this will be applied. Generally, selecting parameters of 20, 20, and 0.5 are going to be best for an initial guess for the best fit for this type of function. Within this function, in order to overlay the amplitude function on my original data, I'll want to make sure that my units match those of the function that I'm placing into these arguments. In this case, I've got angular velocity, so I'll want to match this with radians per second. Let me close my calculator drawer here. To overlay the function that I've just calculated, I'm going to click on this vertical axis when the entire axis is selected. And then I'm going to go down to Add Similar Measurement. Since I've chosen the same units here, I can go down and select my amplitude. So this does a curve fit for my data here. If I were to have any data here that did not fit this, I could go up and select my highlighter, highlight that data point that didn't fit, and then I can then go up to here to either exclude the data or to the right hand side, delete that data point. Now that I have this applied, the entire data set is still selected here. Now that I see that it's actually fitting these peaks very, very well, I can actually hide my original data if I wish to by again selecting on the vertical axis label, going to Add Similar Measurement, and I can deselect my original data. Now I can apply a curve fit to this so I can extract different damping coefficients from this. To do that, I'll go up and select on my curve fit, make sure that is selected, and then I can go down and select my natural exponential. This will give me a curve fit with my different curve fit parameters that you can see the curve fits there very well, and then I can use that for further analysis of my data.